So welcome to CommNet first workshop. I am Sachin Sao, third year, and I am the co-coordinator of this event. So in this workshop, we are going to discuss about the signals and MATLAB. Okay. We have Kanchan, second co-coordinator of the event, and she is also in the meeting. So if you have any doubts, you can clear your doubts in the chat box. I think if you have any doubts, you can use the chat box. Okay. And you can also ask your questions directly using mic. I think everyone can use their mic, right? It is allowed.
Yes, Bhaiya, we can use.
So aim of this workshop is introduction to signal and MATLAB hands-on. So first we will discuss
Sachin,
what
maybe
is
you
signal.
can put it in full screen mode. That would be better. Yeah.
So aim of this workshop is introduction to signals and MATLAB hands-on. So first we will discuss about the signals, where we will know what basically a signal is, and then we will have some practical on MATLAB. So this is just two images of signals. So what is a signal? So a signal is a function of one or more independent variable which contains some information. So it is just in theory. So basically, when you talk, when you see something, the signal, everything around you is in a form of signal. When you're watching something, the light from that object is coming back to your eyes, and is processed by your brain, right? So it is also a kind of signal, which is being received from the object to your eyes and then to your brain. So, but in our case, what in our workshop, we will be discussing the signals, which will be in the form of voltage, current, temperature, etc. And signal is basically a mathematical representation of any physical energy like voltage, current, temperature, etc. If you have any doubts, you can ask your questions, okay, using mic. So what is how can we represent a signal? So in later workshops, we will discuss how can we represent any signal. I am saying any signal with the use of only two basic signals, two periodic signals, sine and cosine. We can represent any signal with the help of sine and cosine signal. Okay. So so we are taking just a general signal y is equal to a sine omega t plus I think there's some mistake here. So just ignore this. So basically, a signal can be identified by following parameters. Amplitude. I think you know all what is amplitude, right? It is the maximum value a signal can take, or signal can take, right? Next, we have frequency. So frequency is inverse of time. Is inverse of time period. The time between two instances in the signal, which is having same phase. And phase is the initial angle which is inside the sine function. So basically these three properties you should know, and you should remember these things, because in the later workshops when we'll be discussing modulation, I know you will be thinking that what is modulation, that will be discussed later. So in modulation, these three properties will play a very important role. Okay, amplitude, frequency, and phase. So you guys should remember this, that any signal can be represented in the form of sine and cosine and their summation, and each of these signal can be identified by following parameters: amplitude, frequency, and phase. So what are the types of signal? So I think you know that signals can be of various types, and if I tell you the names, then I think you can imagine by yourself then how does these signals will be can be represented, like continuous and discrete time signals. Can anyone tell me how can we represent them? That what do you understand by continuous signal, if anyone knows? It is very easy. From the name only you can think. Continuous and discrete time signal. Is there anyone? No one. So all right, let me tell you. So continuous and discrete time signals are the signals. So in case of continuous time signals, we are having the value of the signal for every instant of time. For every instant of time, we are having values of the signal. And for discrete time signals, we are having the values of signals at some constant of time, not for every instant of time. Understood? Again, I'm telling, if there is any doubt, you can tell me. Don't hesitate. Okay, I'm not a professor, I'm just a senior. So next we are having analog and digital signals. I think you all know about analog and digital. If I ask you that how we are that recently not I think a few years have been India has launched digital India scheme, right? Anyone knows about digital India? So we are basically trying to develop the technicalities in the digital field. In analog and digital signals, in analog signals, the amplitudes can take any value. In analog signals, that amplitude can take any value, and in digital signals, the the signal can take only few values. Okay, like here can we see in the images. So here can you see that in continuous signal, it is having values for every instant of time, and for discrete signal, it is having values for only some instant of time. The images are clear to everyone? Anyone response, please?
Yes.
Hello.
Yes, Bhaiya,
So
it's clear.
so in next in the right side we are having analog versus digital. So in analog you can see there it is taking every values from -5 to 5, right? But in digital signals it can take only few values like 0 or 5. It cannot take any other values against other than 0 and 5. If you think that there is a line passing from 0 to 5, a straight line, so it is just a way of representation. It doesn't mean that it is taking any value between 0 and 5. Okay. Next, we are having periodic versus aperiodic signal. So a periodic signal is, I think it's very obvious that a periodic signal is any signal that which will repeat itself after certain period of time. And in aperiodic signal, a signal which doesn't repeat itself after certain period of time. You can, it is very clear from the image, I think. It is written periodic signal in the above and the aperiodic signal in the below. So in the right side, we are having energy versus power signal. So it is a little bit to understand. There is something in this to understand. So if we talk about a signal, okay, so we are representing a signal in 2D x and y axis by time in the x axis and the amplitude in the y axis. So if we want to find, hello, anyone want to say something? Okay, so I'm continuing. So energy signal. So if we want to find out the energy of a signal, so what we will do? So here you can, I think it's little bit blurred. So I'm just telling you, energy is equal to summation of minus integration of minus infinity to infinity x squared t dt. So we have to find the area inside the signal, and we have to integrate it of the square of the amplitude. Okay, at every instant we have to find out the square, and we have to integrate it minus infinity to infinity. And obviously if we are doing the square, then negative will become positive. And in case of power, like sometimes if we find out the energy of the signal, it will be infinite. If we talk about this sinusoidal signal, what do you think? It will be finite or infinite? if we integrate the area inside the sinusoidal signal by taking its square?
Infinite.
Infinite. So we cannot represent its
Infinite.
energy, right? So for representing representing the signals energies, which is not a correct way. So we will find out its power. So power is equal to limit t tending infinity 1 by t integration of minus t by 2 to t by 2 x square t dt. So we will just take a we will just divide the energy by the time period. Okay, that in this case it is from minus infinity to infinity. For a periodic signal, if we think about a periodic signal like sinusoidal signal, so we can calculate the power, we can calculate the area from first zero to second zero, and then we will divide by its half of time period, because from first zero to second zero it will take only t by 2, right? Any response? So let me say again. Suppose we are considering a sinusoidal signal, so it is a periodic signal, right? Just response yes or no if anyone is understanding.
Yes, Bhaiya.
So
Yes, भैया.
so if we are calculating the area, first let us assume that we are converting the sine into sine square. So every negative will go into opposite positive, right? We will be having the amplitude in the positive side only if we convert into sine square. It is correct?
Yes.
Yes, भैया.
So again, if we are considering the area between two zeros, means where the signal is touching the zero, so it will be the time duration will be t by 2, right?
Yes.
So if we find out the area of the square of the sine signal from first zero to second zero, then it will give the energy of the signal for that instant of time. And if we divide that energy by time t by 2, then it will give us the power. So in case of in case of signal which is having infinite energy, we will be finding its power so that we can define its property. Okay, so we to define the some signal we will use energy, and in some other signal we will use power. Like in the above energy signal, the signal is only for some finite values of x, from some negative values to some positive values, and it is not having any amplitude beyond that, right? You can see that. While in case of power signal, it is having the values amplitude are having the values for entire time period. So that's why we will differentiate between energy signal and power signal. Anyone has having doubt? अगर किसी को भी डाउट हो तो पूछ सकते हो. It's a little bit tricky. Don't hesitate, okay? So everyone understood, right? What is energy signal and power signal?
Yes, Bhaiya.
All right. So next is deterministic versus random signal. So random is you know na. Anyone here who is started coding in their first year? Anyone from the first year who has started coding? No one. I don't believe this, that no one from the first year has started coding yet. So leave it. So in coding we have some random generator where we can we use random function, it will generate some random values. So random, you all know, it is some arbitrary value. It will not be, it cannot be determined. Let's wait for a minute. Wait for a minute just. So let's get back to the meeting. So we are discussing about the deterministic versus random signal. So deterministic signal is a signal where we can determine the amplitude. Okay, if we are talking about a sinusoidal signal, just say sine t or sine omega t. So if you are given the value of t, can you determine what is the value of the signal at any instant of time? I think everyone can calculate, right? Sine omega t. If we are given value of omega, value of f, and value of t. Yes or no? Just response.
Yes, Bhaiya.
So it is known as deterministic signal. If we can also consider any other signal like triangular function, triangular signals, rectangular signals, which you will be studying in the later semesters. So if you also discuss about tan signal, then also tan function. So tan function, if we given the argument that is about tan x. So if we know the value of x, we can find the value of tan x, right? So if a signal is in the form of something which we can determine given the value of argument, so it is not a deterministic signal. But if we consider random signals, so these signals we cannot predict what is the values of the signals at any instant of time. Just so a best example of random signal is noise. So previously, when the technology is not so developed, while talking there is so much lagging. The sound was not clear. Even today, when there is a bandwidth inefficiency, then the sound becomes blur, it doesn't clear. So in that case, the noises gets added to the signal which has been transferred from the transmit from this person who is speaking to the person who is listening. Okay, so random signals are the signals where we cannot find the value of the find the amplitude of the signal if we are given the uh, argument like if you're given a time instant and we want to find out what is the value of the signal at that time instant, we cannot determine it. So in that case it would be a random signal, and the best example of random signal is noise. I think it's clear to everyone. So next we will be discussing about bandwidth. So I think everyone has heard the word bandwidth, right? Anyone who knows what
Yes, dear.
bandwidth is? So so let's say we are carrying a signal which is having frequency components from 100 to 200 hertz. Just imagine we are carrying a signal is being sent from a transmitter to receiver. Transmitter means which sends a signal, and receiver means which receives a signal. So when we are transmitting a signal, and suppose it is having frequency from 100 to 200 hertz. So what will be the bandwidth? Bandwidth will be the range of frequencies which is being used in the transmission of signal. So here 100 to 200. So bandwidth will be 100 hertz. Okay. So it is commonly used term for network speed or used by government agencies to sell rights to telecom companies. Like uh, in some movies, you have seen that while they are tuning the radio and they catch some signal, and and if they tune it to the perfect, then they can listen to something which is not audible to our normal ear, right? Have anyone seen this kind of scene? Right. So when so telecommunication is needed everywhere, right? We are talk like I'm while I'm taking the workshop, the signal from my computer is being transferred to your computers. Right now, so many airplanes are flying in the sky, and telecommunication is needed between the airplane and the center from where the signal is being transmitted to the airplane, that continuously where it should fly, right? I think everyone is understanding, right? If you are having any doubt, then you can ask me. Okay. So I'm just telling that while nowadays telecommunication is a very important part. So right now many people are communicating with each other at the same time. So in this time, so everyone is having frequent is so while the signal is being sent from a transmitter to receiver, so many signals are being are being receiving in the all over the world. So all of them cannot use the same frequency. They have to use different frequencies, right? So what I'm telling, let's suppose if I am talking to you and the signal has been using some signals, let's say from 1000 to 200 2000 kilohertz, so no other signal can use those signals, use that frequency, because if those signal is also using same frequency, then there can be some error and it won't be effective. So so the government, what government does, it provides different bandwidth to different companies or whatever the services are there. So they provide the different bandwidth to different centers or the services, so that their bandwidth didn't converge. Okay, like here you can see that AM radios are having some lower frequencies, shortwave radio are having some higher frequencies, then we are having very high TV channels, then FM radio, then VHF TV, then microwaves. So it is not that AM radio will be starting the will use the signals beyond 10 is to 6 or 10 is to 7. Okay, they cannot use it because the government is not allowing them to use them. It is also not feasible for the system. So in a layman manner, if we say what is bandwidth, so bandwidth is just the frequency components which are present in a signal, and here is an image which is mentioned 0 dB and minus 3 dB, and so what is 0 dB and what is minus 3 dB? So let me just discuss it in a little bit way. So everyone knows about log function, right? Yes or no? Hello.
Yes.
So in log, what is the value of log 1? Hello. 0. And what is the value of log 2? If anyone knows.
0.301.
0.301. So while we are calculating so if we are multiplying that number by into 10, so will we get 3.01. If we take a round number, then will we get 3. So when a signal is being transmitted from transmitter to receiver, then it is having different amplitude at different instant of time. So we are representing that amplitude in terms of dB. So dB is equal to 10 log base 10 into amplitude divided by maximum amplitude. So in case when the signal is having its maximum amplitude, so then at that time 10 into log a as a numerator and denominator is same, then it will become 10 log 1, and 10 log 1 is equal to 0. Everyone understood this? I think in JE also they have discussed this 10 log base 10 into the relative amplitude. It is clear to everyone or not? So let me repeat myself. So in relative amplitude is equal to amplitude at any time instant divided by maximum amplitude. Okay. And next, when we are calculating the strength of the signal in dB, then we will just calculate. Then we will write like 10 into log base 10 into a by a max. So in case of the signal is having the maximum amplitude, when the at the time instant when its amplitude is equal to maximum. So at that time, the term inside the logarithmic value is equal to 1, and log 1 is equal to 0. So 10 into 0 is equal to 0. And when the amplitude is half, or when the power is half, then it will become 10 log 1 by 2, that is minus 3. So we are just taking the frequency components at which the, so here it is little bit different. let us take a moment. I'm taking a pause. Okay, be there. Okay. Am I audible to everyone?
Yes, Bhaiya.
Yes.
So basically here whatever the graph which is given here, it is of gain versus frequency. Okay, you know gain, anyone knows gain? So gain, let me just discuss. So if we will be discussing in future workshops, just give I'm giving the basics, like the the gain of a signal depends on its frequency. Okay, so at different values of frequency we are having different gain. So when the gain is maximum, it is equal to 0 dB, and when the gain is half of the maximum, it is equal to minus 3 dB. So we are calculating the frequencies at which the gain is equal to half of maximum gain, and at the frequency corresponding to those gains we will find the difference, and that is equal to bandwidth. Okay, I think everyone understood this. Here in the y-axis we are
Yes.
plotting the gain. Okay, so I think so that's all we should know about the signal. Okay, next we should know we have to discuss something about communication. So we are just suppose I'm speaking. Okay, so the voice signal, the speech from my mouth is converting into electrical signal using my earphone. Okay, next this electrical signal is being processed by this computer, by the laptop which I am using. Next it will be converting into some other form of signals, then will be transmitted to your laptop, then it will again convert it into the electrical signal, and then back to audio signal, so that you can listen, right? This much everyone can understand, or should I repeat it? ये सबको समझ में आया? Hello. So let me repeat myself. So we can everyone can see the image, right? There is having source, input, transducer, transmitter. It is visible to everyone?
Yes. Yes, we are visible.
हाँ, तो बीच में खाली यस भैया बोल दिया करो, ठीक है? जब समझ में आए, जब ना समझ में आए तो ना भैया बोल दिया करो एक बार बस. So in the source, so if the source is where the signal is being produced. Okay, like in this right now I am the source. From me the signal is being transmitted. Okay, my speech is a source. Next we have an input transducer. So anyone knows about transducer? Anyone knows? If you know, you can tell. Okay, yeah, someone is telling something. Hello.
It converts the disturbance or the voice into electrical signals.
Okay, yeah, you are right. So transducer is just an device which can convert a form of signal into other form of signal. So right now what your microphone does, it is converting the speech which is from you into the electrical signals. Okay, so you are using microphone, right? Like right now I'm also using microphone. So this is known as transducer. It is a type of transducer. In it there are also other types of transducer. So and in case of speaker, you know what does speaker does? Anyone can speak? Anyone can know?
It's also a transducer, but it converts the electrical signals into voice signal.
Yeah, you are right. So these things are very basics, right? I don't think so that these things are very difficult to you. If it is, then you can tell me. Okay. If you are having doubt at any point, you can just raise your voice. Okay. So next, after input transducer, we are getting the electrical signal. So in electrical signal, next we are sending it to transmitter. So what does transmitter will be doing? So it will transmit the electrical signal into the channel. This channel now, what is the purpose of the transmitter? So let's say uh, let me take an example of an so right now the signals from my side is going through your side. There is a space, or the atmosphere is there in between, right? The signals from me is being received at your side. There is an atmosphere inside in between, right? Is it going through wire or through the atmosphere? Can anyone can respond?
Wire.
Wire. So any can you tell anywhere that is coming, that is being that is having one end from my side and other end at your side? Just imagine, just think a little bit. My
No,
laptop
bhaiya.
is, tell me any response. The signal is being transmitted from my side and is being received at your side. So there is wire obviously, but it can it be done through only using wire? I'm just saying that.
It
No.
can be through air, I mean atmosphere.
Yeah, so there is a part of atmosphere, right? In some portion there is atmosphere. The signal is being transmitted from a laptop to some satellite, or or direct to your device, maybe whatever the technology it is using. So now let's take some other example. So so in your school you were having functions, right? Anyone having any functions in their school where they are singing, dancing, poetry reciting? You all are having, na?
Yes, bhaiya.
So so there someone is using mic, and the wire from that mic is directly it's connected to the speaker, right?
Mm-hmm.
So there we don't need to convert the electrical signal into any other signal, right? Because there is a wire which can transmit those electrical signal from the mic to your speaker, right? Everyone understood? Everyone is understanding?
Yes, bhaiya.
So but in my but in this case, right now when I am talking to you, there the atmosphere transmit the electrical signal from my side to your side?
No.
No.
No, it is not possible. So so how the signals so how the electrical signal is being sent to your laptops or mobiles, if you are using mobiles? So here transmitter is playing a very important role. Here the transmitter is converting the electrical signal into electromagnetic signal. Okay, everyone knows about electromagnetic wave?
Yes,
Hello.
bhaiya.
So just give me a response that does electromagnetic wave needs any medium to transmit?
No.
No.
if
No.
if there
No.
is a medium, if suppose if there is a medium, so electromagnetic wave can transmit through that medium or not?
Yes.
Yes. So
Yes.
it can transmit if there is a medium or not, it doesn't matter. Okay, so what it is, so transmitter it is converting the electrical signal which is being produced from the transducer, and it is converting into the electromagnetic signal. Now this signal is being transferred from my laptop using some antenna, uh, which is obviously not visible. So can anyone see any antenna in the laptop?
No.
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 So obviously it is not visible. So everyone has seen an antenna, right? An actual antenna, not in your laptop, anywhere else.
Yes.
Yes, bhaiya.
Yes.
Like in
Like
radios.
radio or in
Cars.
cars, any antenna which is quite big enough and is seen everywhere, like in TV dish, this antenna. Everyone has seen this antenna.
Yes.
Yes, भैया.
Yes, भैया.
Yes. So you have if you have noticed that there is a wire from your set-top box to the dish antenna, right?
Hmm.
And after that there is nothing, and after that dish antenna there is nothing. So the signals from your TV or from the TV or from your remote is being transmitted through that dish antenna to the satellite and then to the TV center or whatever wherever it is reaching, right? So that transmission is being done using electromagnetic signal, and the role of transmitter is very important here because it is converting the electrical signal into electromagnetic signal. I think everyone is understanding what I'm saying.
Yes, भैया.
Yes, भैया.
Just one moment. So what does receiver does? Anyone can answer? It is very obvious from the diagram.
EMW से उसे इलेक्ट्रिकल में कन्वर्ट करना.
So it is converting the electromagnetic signal back to electrical signal. Okay, electromagnetic wave or signal back to electrical signal. And then we are having output transducer, which is converting the electrical signal into whatever form of signal it should be receiving, like video signal. It can be in the form of video, audio, right? It can also be formed in form of some other like light, whatever transducer is doing. Okay, it can be temperature. Sorry. So now we'll be discussing some channel. Okay, so channel can be wire. Okay, so when I'm giving the previous examples, when I'm telling that in your schools the function is going on and the signal is being transferred from your mic to the speaker, so there a wire is being used, right? Hello.
हाँ.
So in that case the wire is the channel. Okay, and in that do you think there can be some distortion in these electrical signals which is being transmitted through the wire? Yes or no? Anything you can tell just from your imagination or your thinking.
Yes, भैया.
Means when the electrical signal is being transferred from the mic, okay, through those wires, so there can be distortion or not? There can be some noise in that electrical signal. You're telling yes.
Yes, भैया.
So actually there is not so much noise, okay, because there is no some outer element in there. So it is in optical fiber also there is not so much noise, okay. In there might be some noise, but there's those noise can be negligible, okay. So major noise, can you give an example where noise plays a major role in some channel? First give me some example of channel from whatever you have understood. Except wire, can you give example of some other channels? Anyone?
Atmosphere.
Atmosphere, very good.
Space.
Space. So okay. So so what do you think if I am sending electromagnetic wave through the atmosphere from one end to other end? So there will be lots of much considerable amount of noise will be added to this signal or not?
Yes.
What does your imagination say? Yes. So it is very obvious in the current world. So when it is done, when the experiments are being done or when the observation has been done, then it is found that when the signal is being transmitted from one end to another end using the atmosphere or space, then there is so much noise. Okay, so when these noise are being added to the channel and it distorts our channel, it distorts our signal. So whatever the signal we are sending, we are getting something different in the receiver side. Okay, so this is a problem which we were facing and different techniques, different devices has been invented since then, so that we can have noiseless communication. Okay, do you think we have achieved noiseless communication? Means there is
No,
no noise. No, so
not
we are
through.
approaching. Yeah, you are telling something.
No, matlab, I was saying that not through atmosphere channel.
So yeah, we can use some channel where where we can just minimize the noise to a value which can be ignored, like optical fiber. I don't think there is so much there is much noise in the optical fiber, but in atmospheric communication, atmospheric channel, there is much noise, and we can reduce those noises, but we cannot totally eliminate. Elimination is not possible. Okay, so let me just
Okay.
tell you about one another noise. Okay, so some of the noises can be coming up from the channel. Okay, the path of transmission, and some noise can be coming from the transducer transmitter, because it is converting a form of signal into another, right? And output transducer is in the output side, we are doing the reverse. So in the conversion and anti-conversion, there might be some error. So those are also known as noise. Okay. So those will be also considered as noise. And in case when you are telling that the in the school functions, sometimes the noise becomes so high pitch. You remember? Anyone remembers having high pitched noise coming
Yes.
from the speakers? So in that case, it is due to the devices which are using which are being used. Okay, so there the noise is not due to the channel. There the noise is due to the devices which is being used in those speaker and microphone. Okay, so anyone is having any doubt? किसी को कोई भी डाउट हो तो पूछ लो, हिंदी इंग्लिश किसी में भी, जिसमें भी कंफर्टेबल हो. No doubt. So let's continue. So communication. So there is communication. What is communication? So it is just a process of transmitting information from the source end to the destination end. Transducer is used to convert input physical message into electrical signal and vice versa. Okay. So just let me ask you, in case of optical fiber, we are converting the input physical message into which signal? Is it electrical signal?
No.
Which signal?
Light.
Yes, light.
Electromagnetic wave signal.
Yes. So not electrical signal. Okay. It is something different. Next, we are having transmitter converts of electrical signal into a form that is suitable for transmission. So what I was telling. So transmitter क्या करता है, उस इलेक्ट्रिकल सिग्नल जो भी हम लोग ट्रांसड्यूसर जो भी प्रोड्यूस किया है, उसको एक ऐसा फॉर्म में कन्वर्ट कर देता है जो कि ट्रांसमिशन के लिए उपयुक्त हो, मैंने वो जो कि ट्रांसमिशन के लायक हो. Okay, so it is converting the electrical signal or whatever the signal is being produced from the transducer into a form that is suitable for transmission. Again, one thing, if I tell you let's say you are sending a signal which is having the wavelength 250 meter. Okay, just consider, and for receiving a signal of lambda, the length of antenna required, does anyone knows what is the length of antenna required? Anyone?
Lambda by 4.
Lambda
Lambda by 4.
Very good. So if the wavelength of the signal is 250 meter, so what is the length of antenna required? Length of antenna required?
62.5 meter.
62.5 meter. So
That's a huge antenna.
yeah, that's a huge antenna. So we cannot use so we cannot directly send the signal which is having low frequencies, because low frequencies means where lambda will be higher, and the size of antenna required will also be higher, right? So in that case, we have to do some modulation, and we will be discussing modulation in a little bit time. So in modulation, what we were doing, we are converting into some other form so that we can we can receive those signals using antenna, which we can means practically we can use, okay, like 1 meter 2 meter using 1 meter 2 meter antenna, okay. Like in your dish TV also, what is the average size of the antenna? Half meter? Is it more than 1 meter?
Yes, भैया. No,
More
भैया,
than 1
less
meter?
than 1 meter.
No, less than 1 meter. So we have to modulate the signal so that when it can receive, so it is having the frequency component such that the antenna can receive those signals, okay. So channel, what is channel? The channel is the physical medium that is used to send the signal from transmitter to receiver. So the channel is the medium, okay, just a path. Receiver serves the reverse operation of the transmitter. So what does receiver does? It just reverse the process which is being done by transmitter. If we discuss the types of communication system, anyone is having any doubt on communication system? पूछ लो, छोटा मोटा कोई भी डाउट पूछ लो. इन डाउट.
भैया, what is hybrid communication?
वो डिस्कस करेंगे. That will be discussed. I'm telling anything from what we have already discussed.
डिजिटल और डिस्क्रीट सिग्नल्स में डिफरेंट.
अच्छा, डिजिटल और डिस्क्रीट, तो देखो वो इन डिस्क्रीट we were telling discrete time, okay. So in that case the amplitude can take any value, but it can only take values at some instant of time, okay. Let me go through.
तो भैया जिस टाइम पे वो वैल्यू नहीं ले रहा है तब वो जीरो है.
नहीं, तब वो कुछ नहीं है, वो हम लोग तब उसको कंसिडर नहीं करेंगे. We will not be considering the values at any other time, okay.
Okay.
So it is having the values at only some instant of time, not for all instant of time. That is discrete time. And digital, it means it can have, it will be valuing from throughout the time, okay. So you can see that it for throughout the time it is having values, but these values can also only be fluctuating from 0 to 5 and from 5 to 0. It can only vary between 0 to 5, only 0 to 5. 0 and 5, sorry, not 0 to 5, only 0 and 5, okay. Understood?
Yes.
Everyone understood these things, periodic, aperiodic, energy versus power.
Yes.
Okay. So what is analog communication? So analog signals transmitted by using analog modulation scheme. So in this case, what we are using, like electrical signal is also as analog signal, okay. So we let's say we are using analog signals and we are transmitting the analog signal only, okay. We are not converting into digital signal, okay. Understood? So here the transmission, what the signal which is being transmitted through the channel is analog signal. And in the transducer and in the transmitter part, before the signal is being transmitted, that signal is not converted into digital signal. Then this is known as analog communication. Understood? Yes or no? If you don't understand, just tell me. I will repeat. I will try to explain it in another method. Analog communication समझ में आया सबको? हेलो, कुछ भी बोल दो, नहीं समझ में आया तो वो भी बोलो. If you are not understanding, just tell me. नहीं आया तो चलो फिर से समझाता हूँ. Let's see. So we are just, let's say the source is me right now. I'm producing a sound signal, okay. Understood? Just tell yes or no. So in this case, the sound which is being produced by me, it is converting into electrical signal, and that is also analog, okay. We are not converting it into digital signal. and after that this electrical signal is converting into electromagnetic wave, and then it is being transmitted through the channel, then received, then back to electrical signal, then back to the whatever sound or voice or video. So in this case we are not discussing digital, right? मैंने कहीं भी डिजिटल बोला इसके बीच में कहीं भी? Yes, no?
Yes.
डिजिटल बोला मैंने इसमें?
नहीं
तो ये जो है, so this is analog communications. Okay, we are not converting the analog signal into digital signal. If so, actually when we will discussing in the further workshops, we will also get this idea. With this idea will get more clear. So in digital signals transmitted by using digital modulation scheme. So I told you, right, that there is a problem related to frequency, right, and the size of antenna. Remember? Hello. थोड़ा देर पहले ही बोला था, इतना बहुत दिन पहले भी नहीं बोला था. Size of antenna and frequency related problem. Remember,
Yes.
everyone? So what does modulation does? So so modulation, it converts the signal into some form so that so the size of antenna shouldn't be very much large. Okay. For the time being, just understand this. We are increasing the frequency of the signal. We are increasing the frequency of the signal. Okay. Hello. And we are also converting the properties of the signal, so for better transmission. So there are two methods, analog modulation and digital modulation. So in this if let us discuss this by the diagram. Okay, in analog communication system, everyone is understanding, right? सबको समझ में आ गया? Everyone understood? एनालॉग कम्युनिकेशन सिस्टम, ये डायग्राम सबको समझ में आ रहा है? आवाज नहीं आ रही तुम लोग की, सॉरी. यस और नो कोई बोल दो.
Yes.
ठीक है, चलो डिजिटल कम्युनिकेशन में समझाता हूँ. देखो ये ब्लॉक डायग्राम अब समझ में आएगा तुमको. So here is a information source, right? It is visible. Let's zoom it. It is visible. जो लिखा हुआ वो दिख रहा है, इंफॉर्मेशन सोर्स, इनपुट, ट्रांसड्यूसर, ये सब दिख रहा है?
हाँ भैया दिख रहा है भैया.
चलो ठीक है. So there is a information source and input transducer. So let's say we are getting analog or digital. Okay, we will be getting anything, analog or digital. Next we have source encoding. So if it is digital, then it's okay. If it is analog, then we will be converting into digital signal. Let's see, you can find it is 1101. You know binary binary numbers?
Yes.
Everyone knows binary, that is 1001. Binary can take only two values, 1 and 0, and in digital the signal is having only two values, 0 and 1. Okay, so we are converting the analog signal into the digital signal. Okay, next we are doing some channel encoding. We will be discussing all these things. Okay, source encoding, channel encoding in next slide. So in channel encoding we will be doing some more modifications in the signal. Okay, so you can see, right, there is no analog signal. We are converting 1101, 110101. Only is digital signal. Okay, yes or no? Any response? Okay, next we have digital modulator. So yeah, also try to remember one thing. Okay, whenever we are using atmosphere, okay, or any channel, so we cannot send digital signal directly. We cannot send signal which is have only fluctuating between 10 1010. Okay, try to remember these things, because I was when I was studying this in my semester, I was also get confused in the beginning. So I'm just telling you, don't think that in digital signal, the signal in digital communication system, the signal which is being transmitted is only having value 0101. Okay, in the initial phase, we are converting the analog to digital. Okay, it is clear from the diagram. Hello.
Yes, Bhaiya.
Yes. Next, what we are doing, we are changing the property of electromagnetic wave using those digital signal. Okay. So we are changing the electromagnetic wave property using those digital signal, and then this electromagnetic wave can travel through the channel. Then it will go to digital demodulator. What it will convert? It will convert the electromagnetic wave into back to binary. Then channel decoding, there's source decoding. Then from that we will getting analog or digital. If in the initial we are having analog, then we will get analog. If in the beginning we will be having digital, then it will be converting into digital. Okay, understood? कोई डाउट हो तो
भैया।
पूछ लो, नहीं तो फिर से समझाऊंगा बोलोगे तो. Should I repeat? Anyone want to repeat it? Means anyone wants to understand this again? See, these are very basics, and this might be easy, might be difficult, but understanding these things is very necessary. Okay, for the future workshops. Because in the future workshops, when I will be discussing, I might not be getting time to discuss all these things again. So try to understand these things in a better way, properly. Okay. If you have any doubt, just ask me. Anyone is having any doubt?
Bhaiya, what is encoder and decoder?
Encoder and decoder. Yeah, we will be discussing in the next slide. Okay. So let's just reduce this. So source coding. Encoder, what it is converting your message into something which is not actually your message, it is something else. Okay, which will be transmitting. And decoder is converting, is doing the reverse process, like source encoding. If I'm telling like this, see, let's say you are having let's say there is a something A B C A. Okay, let's say we are having a signal A B C A. Okay, yes or no? Just let's consider we are having signal ABC and we are converting into digital. A to for 00, B to 01, C to 10. So here encoding is converting what? It is converting us our signal into some binary representation. Okay, so that's called encoding, and decoding just does the reverses. So what is source coding does? It reduces the redundancy. Redundancy means
But Bhaiya, can we use direct the signal from transducer and we skip the part of encoder and decoder? Then what will be the output?
like we were using transducer and then no encoder, then it will become
No,
normal
no
analog
encoder, no
communication
decoder.
system. So in Indian it will
Okay.
become normal and analog system, analog communication system. Okay,
Okay.
actually why we are converting into digital we will also discuss. We are going very slow, just so reduce redundancy. So what is redundancy? So redundancy is that the signal is having some portions, is the portion of signal which is not very useful. Okay, just remember that redundancy is the means that portion of the signal which is not useful. So we will try to reduce those redundancy. We will only consider the portion of the signal which is very important, right? Like if we go to that slide. Okay, here. So in case of bandwidth calculation, we are only considering the -3 dB frequency, right? We are ignoring the else other frequencies, right? It is visible to everyone? Hello.
Yes, भैया.
हाँ, तो यहाँ पे हम लोगों ने बाकी फ्रीक्वेंसी को इग्नोर कर दिया, हम लोगों ने सिर्फ एफएल से एफएच को ही कंसिडर किया है. तो ये जो हम लोग, तो वही मैं बोल रहा हूँ यहाँ पे क्यों, तो हम लोगों ने बाकी को इग्नोर कर दिया. ठीक है, तो उसको बोलते हैं रिडंडेंसी को हटाना, रिड्यूस करना. effective utilization of bandwidth. So, using source coding, we can use the bandwidth effectively. Means we can reduce the bandwidth required for the transmission. Next is data compression. So we can compress the data also. We will discuss in the future workshops. Okay, how we can compress data. Channel coding. So channel coding provides noise immunity by adding redundancy. Now see, we are removing redundancy and next we are adding redundancy. So we are adding some extra bits. You can see here, right? 1101. We are adding 2 extra bits 01, right? Hello.
Yes, भैया.
हाँ, तो हम
Yes,
लोग यहाँ
भैया.
पे जो सिग्नल का जो साइज है उसको बढ़ाया हम लोगों ने. अब बढ़ाने के बाद हम लोग क्या कर रहे हैं, क्यों हम लोगों ने बढ़ाया, ताकि ये हमारा एरर करेक्शन में हेल्प करेगा. हमें पता चलेगा कि एरर है कि नहीं. अभी कैसे पता चलेगा ये हम लोग फ्यूचर वर्कशॉप में डिस्कस करेंगे. ठीक है, अरे समझ लो चैनल कोडिंग व्हाट इज इट डूइंग. It is adding some redundancy, it is adding some extra blocks, it is extra values, so that we can find out the received signal is corrupted or not. Okay, and it can also helps in the error correction, error detection as well as error correction. Modulation, it is converting the low frequency electrical signal into high frequency modulated signal. It is converting low frequency electrical signal into high frequency modulated signal. And there are also different kind of modulation which we will be discussing in the next workshop. Next we are having analog signals. So why we should use analog signal. Okay, so it provides more accurate representation of a sound. Yeah, so you can represent a sound in the analog form only, right? Can you represent it 1010? Do you think? Hello. So let me continue. So it is best fitted for audio and video transmission. It is easier in processing. It is using less bandwidth, and implementation is easy and cheap. Okay, so disadvantage, encryption is not effective. So when we are transmitting a signal, we cannot encrypt it effectively. So the privacy is a problem here for analog signals. Has infinite number of values and thus would require that much precision to store. So it can have infinite number of values. So storing it is little bit difficult. It is not immune to noise. Okay, analog signals is having a noise problem. While in case of digital signal, so security and privacy, yes, it is very effective in case of security and privacy. It is efficient multiplexing. We will discuss in next slides. Data compression, error detection, error correction. I already discussed in channel coding, source coding. High SNR, signal to noise ratio. If noise is very less, then signal to noise means signal power divided by noise power will be very high. So in digital signals, SNR value is very high. That is, noise is very less compared to signal power. Next disadvantage, if we talk about complex circuit, synchronization is compulsory. You can also see that there are also two extra devices being connected here, 2 extra blocks. So the circuit is complex, synchronization is compulsory. Bandwidth is high. So in digital signal, bandwidth is high. Okay, and there is also high power consumption, because there are some extra blocks which will need some power sources to run. Okay, SNR and noise immunity. So what is SNR? So measure of the strength of the desired signal relative to background noise. Okay, do you know what is the desired signal and background noise? Right? Just say yes, by or no, or if you're not understanding. So ratio is typically expressed as a single numerical value in decibels. Okay, so we are expressing those values in decibel. Okay, as signals having high value of SNR are more immune to noises. See, if we are having high SNR value, means signal power is very much high in comparison to noise. Okay, so we can easily ignore the noise with respect to signal, right? Am I right?
Yes, भैया.
Okay. So in from the graph, you can see that when we are adding a noise to a signal, it is. So can we predict the values in the analog signal? Can anyone predict the values from the analog signal? which is being noiseful. इस सिग्नल में नॉइज ऐड हो चुका था, तो क्या
ओ
तुम अब
भैया।
पता लगा पाओगे? इसमें नहीं पता लगा पाओगे, पर ये डिजिटल सिग्नल में तुम पता लगा पाओगे, हाँ या ना? हाँ, ये बहुत इजी है कि ये 1 है, ये 0 है, राइट?
हाँ भैया।
हाँ,
लगा
तो ये
सकते हैं
यहाँ पे
भैया।
हाँ, तो नॉइस का अगर वैल्यू कम हो तो एनालॉग में काफी डिफिकल्ट हो जाता है। एनालॉग में देखो वो वैल्यू कंटिन्यूसली चेंज हो रहा है, so we cannot tell the exact value, but in a digital signal we can predict, okay, it is 1 or 0. There might be some error, but precision is much better in digital signal. Next is encryption. So in digital encryption, the analog signal is first digitized. I have shown you, right, like the analog signal is being converted into 1101, okay? So it is first converted to digitized. And if we right now, if I'm while I'm speaking to you, the signal is also converted into 1101 whatever. So if I give you a number of a bit stream 1101, so can you identify what I'm saying from that 1101? Anyone? कोई क्या पता लगा पाएगा उस 1101 का बिट स्ट्रीम से, बाइनरी बिट स्ट्रीम से क्या बोला गया, नहीं बोला गया? अगर उसको डिक्रिप्शन नहीं आता होगा तो नहीं बोल पाएगा। तो ये वही, तो डिजिटल कम्युनिकेशन सिस्टम में इंक्रिप्शन बहुत ही एफिशिएंट होता है। इट इज वेरी we can use encryption in various methods in digital signal. In analog communication system it is possible, but it is not effective, okay? So next is multiplexing. So multiplexing is just a wise use of available bandwidth to achieve specific goals. Efficiency can be achieved by multiplexing, that is sharing of bandwidth between multiple users. We will be discussing the next slide. See, here we are dividing the bandwidth which is available to us to different user. This is visible. Let me just, सबको दिख रहा है? सबको दिख रहा है ये बैंड? ये मान लो ये जो है फ्रीक्वेंसी का ये है, ठीक है? हम लोगों ने फ्रीक्वेंसी को डिवाइड कर दिया। TP1 को अलग फ्रीक्वेंसी मिल रही है, TP2 is getting another frequency, TP3 is getting another frequency, and TP4 is getting another frequency. It is visible to everyone?
Yes भैया.
Hello. So we can send the different signal at the same time, and the different signals are using different frequencies, okay? While in time division multiplexing, we are sending the signal from different source at different time instant. Like first we are sending A1, then B1, then C1, again A2, B2, C2, again A3, B3, C3. So in this case, the receiver should know, say that when it should start, like this is the time instant it should start collecting A1, B1, C1. अगर रिसीवर को नहीं पता होगा कि उसको A1 कहाँ किस टाइम मोमेंट में मिला है, तो वो सही से पता लगा पाएगा किसके पास भेजना है मेरे को? तो वो यहाँ पे तो कंफ्यूज, मैं हिंदी में कंटिन्यू कर रहा हूँ, ठीक है? थोड़ा अगर किसी को इंग्लिश में बोलना हो तो बता देना, मैं बता दूंगा फिर से इंग्लिश में। देखो, A1 से सिग्नल गया, फिर हम लोगों ने B1 से सिग्नल भेजा, फिर C1 से सिग्नल भेजा, ठीक है? ऐसा हम लोग कंटिन्यूसली करते जा रहे हैं। रिसीवर साइड में पता होना चाहिए ना हम किस टाइम इंस्टेंट में हम A1 पे सिग्नल ले रहे हैं, B1 पे ले रहे हैं, C1 पे ले रहे हैं, हाँ या ना?
हाँ भैया.
हाँ, तो रिसीवर को ये पता होना चाहिए। अगर नहीं पता होगा, इफ रिसीवर डज नॉट नोट the time sequence that at which these signals are being collected from the different sources, then it cannot receive, there is no use to receive the signal, okay? If it does not know when to send which signal to which source, which receive, okay? So in time division multiplexing, we are dividing the time. It is clear or not? Just understand it. We are dividing the time, okay? So yeah, now the theory is done. So we will be doing some practical, okay? So today practical won't be much difficult, okay? So anyone is having MATLAB in their laptop?
Yes भैया.
हाँ भैया.
Acha, I've got some that some students cannot install MATLAB, right?
हाँ भैया, वो क्रैश हो जाता है एक्चुअली लाइसेंस उसका.
लाइसेंस क्रैश हो जा रहा है तो
भैया
तुम लोग
हाँ
तो
मतलब
वाईफाई
लगता
to
है कि
run the
लाइसेंस नहीं
MATLAB?
है।
एक एक करके बोलो
Do we need college Wi-Fi to run the MATLAB?
हम्म, क्या बोला फिर से बोलो रिपीट
Do we need college Wi-Fi to run the MATLAB? Like we're getting license issues and licenses doing that there's some firewall issue like administration like they're asking to contact the administrator.
ओके सो ठीक है तो मैं इसको बाद में एड्रेस करूंगा ठीक है आई विल बी एड्रेसिंग दिस प्रॉब्लम्स इन द later time okay actually I am not using I'm using Linux so I have installed the MATLAB in another way okay so after coming to hostel I will address all those problems okay ठीक है सबको समझ में आया मैं हॉस्टल में आने के बाद ये सब प्रॉब्लम देख लूंगा ठीक है कि इनका
Okay.
MATLAB में क्या इशू हो रहा है ठीक है till then I will be giving some resources you can read those resources and whatever I will be discuss now in the MATLAB it is very basic okay what I'm discussing to the in the MATLAB okay so let's start with MATLAB okay so I'm stop this sharing I will be sharing next the MATLAB window आज का स्लाइड में अभी तक किसी को कोई डाउट हेलो आई एम नॉट गेटिंग एनी साउंड सो अगर किसी को कोई भी डाउट हो तो वो टीम्स में व्हाट्सएप ग्रुप अभी बन जाएगा उसमें भी लोग अपना डाउट पूछ सकते हैं ठीक है यू कैन आस्क देयर डाउट्स देयर सो राइट नाउ आई एम जस्ट कंटिन्यूइंग विद द मैटलैब
फीडबैक फॉर्म एंड वर्कशॉप व्हाट्सएप ग्रुप का लिंक चैट बॉक्स में है
अब मिल गया ना सबको एक मिनट चैट ग्रुप में आ गया क्या लिंक सब ठीक है चलो तो मैं मैटलैब में कंटिन्यू करता हूँ ठीक है वैसे स्लाइड्स भी मैं शेयर कर दूंगा आई विल बी शेयरिंग द स्लाइड्स एंड देन द लास्ट स्लाइड यू कैन जॉइन द व्हाट्सएप ग्रुप देयर इज अ लिंक ओके सो लेट मी शेयर सो मेरा मैटलैब वाला विंडो सबको दिख रहा है यस नो एम आई ऑडिबल
हाँ भैया दिख रहा है भैया परफेक्ट
चलो ठीक है स्टार्ट करते हैं सो बेसिकली हम लोग सी सो फर्स्ट ईयर में किसने तुम लोगों को कोई भी लैंग्वेज नॉर्मल कोडिंग लैंग्वेज किसी को कुछ पता है फर्स्ट ईयर से पूछ रहा हूँ मैं सेकेंड ईयर में तो सबको पता होगा एनीवन फ्रॉम फर्स्ट ईयर हु नोज लिटिल बिट कोडिंग पाइथन पता है सी देखो तुम लोग अभी स्टार्ट करोगे मोस्टली सब लोग अभी स्टार्ट करोगे या फिर जिनको पता है तो उनको पता है वो सब लैंग्वेज से बहुत ही मिलता जुलता होगा इट विल बी वेरी सिमिलर टू दोस पाइथन एंड सी एंड एवरीथिंग द बेसिक्स विल बी वेरी सिमिलर the formatting will be different okay and who does and the people who don't know any coding so it is also very easy for them also okay so uh, in class 7 or 8 mathematics class you know about the variable right we just assign some random alphabet a b c to some values and then we find those values okay you remember while variables a we have to find the values of x and y anyone हाँ तो देखो तो हम लोग वो वेरिएबल यहाँ पे क्रिएट करेंगे ठीक है सो द रूल्स फॉर द वेरिएबल्स क्रिएटिंग आर दैट इट शुड बी स्टार्ट फ्रॉम एनी alphabet and it can contain alphabet numbers and underscore okay It cannot contain any other character. Okay, so I can write ATE underscore 97787. So I cannot write, this is not a variable name. Okay, it will not take it as a variable name. We can only use alphabets, numbers, and underscore. Okay, and we cannot start with number. Okay, so let's say we are creating a variable which is y. Let's say y is equal to 5. When first let me tell you something about the MATLAB. Okay, so I'm using MATLAB 2018. Okay, you can see it is written MATLAB 2018. So this is command window. Here whatever you will be typing those, and after pressing enter, this this code is been executed and the variable has been created with the name y and with the value 5. Okay,
Yes, Bia.
here the code is written already, which is from the seniors from the 4th year, I think. So in the command video we will be writing the codes and we will be executing it, and in the workspace these variables will be shown. Okay, whatever variables we have been creating in the command window, it will be shown in this workshop. Okay, and here we are having the files and folders, okay, in which we are currently working. Let's say I am writing x is equal to y. So what will it do? Anyone? It is very easy, just response. Okay, if anyone. यार देखो मैं तुम लोग का टीचर तो हूँ नहीं, जस्ट सीनियर, तो जस्ट रिस्पॉन्स करो थोड़ा। x इक्वल टू वाई करने से क्या होगा, क्या लगता है? हेलो,
y की वैल्यू x में चली जाएगी।
हाँ, y की वैल्यू x में चली जाएगी, पर बट y विल रिटेन इट्स वैल्यू, राइट? y अपना वैल्यू रखेगा, ठीक है? सो लेट्स सी, सो वी आर गेटिंग x इक्वल टू 5, y इक्वल टू 5. सो another thing that is, अगर हम लोग कोई भी कोड लिखते हैं, if I am writing a code, then it will be printing its result. Okay, if I don't want to print its result, okay, let's that is x is equal to 5, then we will write like this: z is equal to x so what will it do? It will not output the result. Okay, when I'm typing enter, so as a variable has been created with name z, value 5, but its output is not been shown. Okay, understood?
हाँ भैया।
So basically अब MATLAB की बात करें तो MATLAB, why we are using MATLAB? Okay, so MATLAB it's a short form of matrix laboratory. It is a short form of matrix laboratory. So MATLAB is very efficient for calculation regarding matrices. Okay, so in when we are doing matrices multiplication, addition in the Python and the C++, we have to write so many for loops. The people who are familiar with the coding will understand. Who doesn't know coding, don't worry, we will be discussing all those basics. Okay, so we are using MATLAB so that we can we can do the problems regarding matrices very effectively and very easily. Okay, we will not be writing so many lengthy codes, just 2 or 3 things, and the code will be executing matrices multiplication very easily. So executing them. So next we will be creating some array. Let's say a is equal to, so for creating an array we will be using square bracket. Okay, 1, so here we are getting error because I'm used this wrong symbol 1. So we are not printing anything that a is equal to what, but here a is being created with array which is having value 1, 2, and 3. Okay, so which array? If we ask you, what is this, row or column vector? Just suppose row array or column array. Anyone? Or row matrix or column matrix? What is this?
Row matrix.
Row matrix, because it is having values in the row. If we want to convert it into matrix, column matrix, so what I can do, I can write just A is equal to there is a button in below escape, right, where there is a tilde, but tilde, and there is a dash. So you can use that button, use that symbol to convert what it is giving. Okay, so sorry, my mistake. Yeah, A is equal to A dash. Oh, sorry, that was wrong. So A is equal to A dash. Now let me show you. See, can you see the values? A is equal to 1, 2, 3 and B is equal to 1, 2, 3. सबको दिख रहा है?
हाँ भैया।
हाँ, तो A और B में कुछ अंतर दिख रहा है?
B row matrix।
यहाँ पे सिंपल कॉमा है, यहाँ पे सेमीकोलन है, दिख रहा है? हाँ, वन सेकेंड. वन ए में सेमीकोलन, बी में कॉमा दिख रहा है सबको? हाँ या ना बोलो. देखो सेमीकोलन जो है ना, वो रो को सेपरेट करने में मदद करता है. अगर मैं लिखूं A इज इक्वल टू 1 सेमीकोलन 2 सेमीकोलन 3, तो मतलब यहाँ पे जो 1 जो है वो पहला रो में, 2 जो सेकंड रो में, 3 जो है वो थर्ड रो में. जबकि यहाँ पे B में लिखा हुआ 1, 2, 3 मींस ऑल द वैल्यूज, ऑल द 1, 2, 3 आर इन द सेम रो. ओके, दैट्स अ डिफरेंट, दैट इज व्हाट आई एम ट्राइंग टू मेक यू अंडरस्टैंड. और अगर ट्रांसपोज करना होगा तो सिर्फ डैश का यूज कर सकते हैं, जैसे हम लोग नॉर्मल मैथमेटिक्स यूज करते हैं, which we are using in normal mathematics. The button just the key just near the enter. Okay, just left to enter key, we can use that button and we can find it transpose. Okay, you know matrix transpose, everyone knows, I think. Just tell yes or no.
Yes, yes.
Very good. So next I think so we let's say so we have created some values A, B, X, Y and Z. Let's say now I don't want to do anything, I want to continue this into on next day. Okay, and this laptop will be used by someone else. मान लो अभी मैं जो भी ये सब मैं वेरिएबल बनाया हूँ, मैं कुछ कैलकुलेशन कर रहा हूँ, आई एम डूइंग सम कैलकुलेशन, आई वांट टू प्रिजर्व दिस वैल्यूज ऑफ द वेरिएबल्स. ओके, so how will I do this? How can I accomplish this? So I can use save, I can give any name. Okay, like let's say Sachin dot mat. Okay, and when I'm executing this, it will save those values in sachin.mat file. Understood what I'm saying? अब मैं अगर B में, अगर मैं मान लो अब मैं B को चेंज कर देता हूँ जस्ट, so now B has been changed, right? सबको दिख रहा है B चेंज हो गया? खाली yes और no बोल दो एटलीस्ट, ताकि मैं समझ सकूं यहाँ समझ में आ रहा लोगों को.
हाँ भैया।
हाँ, तो हम लोगों ने B को चेंज कर दिया, ठीक है. पर अगर मैं वापस से लोड, अब मैं लिखूं लोड सचिन डॉट मैट, तो वापस से B का वैल्यू जो पुराना वाला वैल्यू हो जाएगा. ये क्यों हुआ? क्योंकि हम लोगों ने जो we are storing the values in the sachin.mat and we load when we load that MATLAB file, it will again show the values which is stored previously. Okay, anyone, any problem here? किसी को प्रॉब्लम है तो बोल दो. Okay, I will continue. So there are some basic functions in the built-in functions in the MATLAB, like absolute. It is similar to C++. If we write z is equal to, let's say I'm writing x is equal to minus 6. Yes. Is equal to minus 6. So x, the value of x has been changed with negative number minus 6, and I'm writing z is equal to absolute x. देखो z is equal to 6 हो गया. Absolute का मतलब सबको पता है. Everyone knows about absolute. It is just converting the negative to positive and positive to positive only. Okay. Next we can write square root. Square root is also built-in function which will find the square root. It can also find the square root of negative as well as positive number. Everyone knows about imaginary number. Anyone who doesn't know? अगर नहीं पता तो नेट में सर्च कर सकते हो इमेजिनरी नंबर क्या होता है, मिल जाएगा सबको. Let's say I'm writing m is equal to sqrt. m is being printed with some real 0 and imaginary some number 2.4495. If we square that number we will get minus 6. Okay. There are two things, format long and format short. Format long will print the number of digits after decimal, so many digits. Okay, means it is having high precision, format long. And whatever we are printing right now, it is format short. Okay, so if I'm writing format long, then I'm writing m. So see here the number after the decimal is increased. Okay, everyone can observe this. सबको दिख रहा है ये? सबको दिख रहा है? चलो आगे कंटिन्यू करते हैं. अब मान लेते अगर हम पाई का वैल्यू अगर हम लिखते हैं n इज इक्वल टू पाई. देखो पाई का वैल्यू बहुत ज़्यादा प्रिसाइज वैल्यू दिया गया यहाँ पे. इफ आई एम गेटिंग फॉर्मेट शॉर्ट then I'm printing the value of n, then it will give only 4 decimal digits, 4 digits after decimal. Okay, so format long and format short, you can use whatever according to your requirement. Okay, so next is evenly spaced vector scenario. Okay, so let's say we want to create an array from, let's say I'm writing c is equal to 5, 8. And I'm entering. So it will create all the values from 5, 6, 7, 8 with a difference 1. Okay, it will be creating a matrix with variable name c, and it will store values 5, 6, 7, 8, which is having the difference 1. If we want to change the difference, like let's say we want to set the difference between 0.5, so we can write c is equal to 5 colon 0.5 colon 8. So it will print 5, 5.50, 6, 6.50, 7, 7.50, and then 8. If we don't know about the difference, we want to if we know only the number of element in between 5 and 8, then we can use another property, that is linspace. Okay, it is known as linspace. Let's say d is equal to lin. You can see it has created 11 elements including 2 and 3, and it is in between 9 elements 2 and 3. Okay, so in total it will create 11 elements in between the starting from 2 and ending into 3. It is a property of linspace. Okay, if you want to create a evenly spaced vector and you know the number of element, you don't know the number of what is the gap in between the individual elements, so you can use this linspace. If you know the gap, you can use this 5 colon gap colon the ending element. Next, let's discuss about the 2D how we can create 2D vector, okay, or 2D matrices. E is equal to, as I've already mentioned, so yeah, semicolon is can be used to separate the row, okay. If I'm writing 1 2 3 semicolon 4 5 6, then we will 4 5 6 will be stored in the next row, okay. And try and remember that the number of elements in each row should be same, okay. You know, in matrices you cannot have 3 elements in the first row and 2 elements in the second row. It is not possible. If I'm trying to do so, it will give an error. Let's try 2 3 semicolon 4 5. The dimension of arrays being concatenated are not consistent, so it is giving an error, okay. So we cannot do that. So next we will be discussing about some functions called.
Can you please again
Let's say,
explain the lean space?
क्या हुआ? Repeat.
Lean space.
Lean space what?
I mean how it is printing the values. Can you explain the process?
So it is creating 11 elements, including 2 and 3. Okay, so it is creating equally spaced elements, okay. Like what is the gap between 2.1 and 2? 0.1 and 2.2, 2.2 and 2.1, 0.1.
Yes, I understood.
So the first is the starting element, next is the ending element, and the next is the number of elements, okay, total number of elements, okay. Yeah, and also remember that we cannot divide it into 10 equal gap if by writing 10. For creating 10 equal gap, we have to write 11, okay. You can just notice this here. So here we are having E is equal to 2D matrix, which is having the 1 2 and 3 in the first row, 4 5 6 in the second row. If I want to transpose, we can use E equal to E dash. Will convert it E 1 4 2 5 3 6, okay. Everyone knows transpose, right? अगर कोई भूल चुका है, अगर कोई ऐसा हुआ कि कोई भूल चुका हो तो नेट में सर्च कर सकता है, बहुत ईजी है. Like everyone remembers identity matrix and zero matrix and diagonal matrix. कोई बता सकता है आइडेंटिटी मैट्रिक्स क्या होता है? What is identity matrix? Anyone?
The diagonal elements are 1.
Can you repeat please? Repeat कर सकते
The
हो please?
diagonal elements are 1.
हाँ, diagonal elements 1 होगा, बाकी सारे elements 0 होगा, right? So if I write identity is equal to ones, and identity matrix square matrix होता है कि rectangular भी हो सकता है? स्क्वायर मैट्रिक्स होगा. तो उसके लिए हमें एक डायमेंशन की जरूरत है कि 2 डायमेंशन की जरूरत है? मतलब एक डायमेंशन अगर मैं दे दूं, if I am writing only 2, so it will automatically consider it 2 cross 2, right? We don't have to mention two dimension, okay. If I'm writing 3, it will just print 1. It is printing once, okay. It is not identity matrix. Identity matrix क्या था? Let me remember. मैं अब भूल चुका था, सॉरी। यहाँ पे मैं लिख सकता हूँ I3 I1 से बस 1। देखो यहाँ पे आइडेंटिटी मैट्रिक्स बन गया, सबको दिख रहा है। तो आइडेंटिटी मैट्रिक्स का क्या लिखना पड़ता है, EY थोड़ा सा अलग है, इट इज लिटिल बिट डिफरेंट। Next we can also create some random matrix if you want. X is equal to random RAND, and we will mention the dimension. If we only mention one dimension, then it will convert it into square matrix. Okay, like if X equal to random 2 square matrix, and it will always print values. It will always take value between 0 and 1. Okay, it will take value between 0 and 1. Next, I'm writing y is equal to random 2. So it is also taking values from 0 to 1. Okay. Okay, let me ask a question. Like in C++ or C in Python, indexing start from 0 or 1?
0 भैया.
0. But in MATLAB, the indexing start from 1. Okay, remember this. If I am writing y, it is printing y1 is equal to 0.6324. Let's say, can anyone answer what will y3 give? क्या देगा प्रिंट करने पे, बताओ, कोई बताएगा? एनी गैस, कोई तरीका? ये तो y 2D है कि 1D है, ये कोई बता दो पहले। y is a 2-dimensional matrix और 1-dimensional matrix?
2D भैया, 2D.
2D है, पर यहाँ पे हम लोग y3 लिखा, सिर्फ एक चीज मेंशन कर रहे हैं, तो ये क्या करेगा बताओ, कोई आइडिया?
पहला वाला दे देगा भैया.
हाँ नहीं, तो यहाँ पे क्या होता है ना, यहाँ पे इफ वी आर गिविंग ओनली वन, पहले प्रिंट कर लेते हैं, देखो 0.2785 आया, so it will be counting from first in the first column 1 2 3 4. Okay, that is 0.6324 is the first, 0.0975 is the second, and then again from the second column 0.2785, 0.5469. If we are having different many other rows, then it will be continuing. Okay, किसी को समझ में आया ये वैसे क्या?
हाँ भैया आ गया.
ये कॉलम वाइज इंडेक्सिंग कर रहा है, पहले पहला कॉलम में, फिर सेकंड कॉलम में, फिर थर्ड कॉलम में. अगर हम लोग इफ यू आर मेंशनिंग बोथ डायमेंशन, इट इज 523 0.9649, इट इज ऑब्वियस सेकंड रो थर्ड कॉलम. ओके, ठीक है, देखो everyone can see the value of z and y, just confirm.
हाँ भैया.
हाँ दिख रहा है. चलो किसी को कोई डिफिकल्टी लग रही है क्या इसमें, मतलब बोल दो कोई. एनीवन इज फेसिंग एनी डिफिकल्टी है? नो भी बोल सकते हो, नो इज आल्सो एन आंसर. किसी को कोई डिफिकल्टी लग रही हो तो बोलो, नहीं भी लग रही है तो वो भी बोल दो बस, ठीक है. अच्छा ये बताओ z का डायमेंशन क्या है, कोई भी, एनीवन, व्हाट इज द डायमेंशन ऑफ z मैट्रिक्स?
Three cross two.
3 cross 2. And what is the dimension of y?
2 cross
What? Please repeat.
2 cross 3.
So can we multiply z into y? Can we implement z into y?
हाँ हो सकता है.
हाँ तो हम लोग कर सकते हैं, राइट. मैट्रिक्स मल्टीप्लिकेशन पॉसिबल है ना z y में?
हाँ भैया.
हाँ पॉसिबल है. तो हम लोग क्या लिखेंगे, z, let's see, we are creating another variable, z and y. Okay, so let's say x is equal to y star z. It is just matrix, it is printing the matrix multiplication. Okay, so you can try, जिनके पास MATLAB है वो लोग तो ट्राई कर सकते हैं, जिनके पास MATLAB नहीं है तो वो कुछ दिन में हम लोग मतलब मैं देख लूंगा कि MATLAB क्यों नहीं इंस्टॉल हो रहा है, ठीक है। बाकी उसके होने के बाद तुम लोग ये चेक कर सकते हो, कैन वेरीफाई दैट इट इज प्रिंटिंग द मैट्रिक्स मल्टीप्लिकेशन, ओके। इतना तो कर सकते हो तुम लोग। अगर बाद में किसी को स्क्रीनशॉट लेना तो स्क्रीनशॉट लेके देख सकते हो, बाद में चेक कर सकते हो कि ये मैट्रिक्स मल्टीप्लिकेशन कर रहा है कि नहीं कर रहा है, ठीक है। पर we can also implement some basic arithmetic like x plus minus if I let z is equal to x plus y. Matrix dimension must agree. So किसको समझ में आया यहाँ पे क्या हुआ?
हाँ भैया।
डायमेंशन सेम होना चाहिए।
हाँ, डायमेंशन सेम होने चाहिए। तो यहाँ पे मल्टीप्लाई तो हो गया, पर यहाँ पे प्लस जो है वो नहीं हुआ, ठीक है। अगर हम लोग दोनों को सेम मैट्रिक्स बना दे तब वो हो जाएगा। तो लेट्स से आई एम प्रिंटिंग y is equal to z कितना, z is 3 equals to अब y प्लस z हो जाएगा, क्या लगता है? प्रिंट हो गया, ठीक है। क्या y और z का डायमेंशन सेम है, ठीक है। ये सब तो पता ही होगा ना सबको।
हाँ भैया।
हाँ, तो x प्लस y और z का डायमेंशन सेम है तो उसको सिंपल ऐड कर सकते हैं, कुछ है नहीं इसमें। There is nothing more anything difficult. It's just basics from class 12 mathematics. You can also let's see y minus z is also printing y minus z, okay. So now see if you want to do some operations element wise, like first row first column of y into first row first column into z, only that, not matrix multiplication, understood? मान लो दो मैट्रिक्स है A B, A11 A12 A13 A21 A22 A23, ये रिप्रेजेंटेशन समझ में आता लो सबको? A11 A12 ये सब याद है थोड़ा?
हाँ याद है।
हाँ, तो हम लोग if we want to multiply A11 into B11 and A12 into B12, so we will use a dot, okay. Let's say I'm writing x is equal to y. So here y and z is having same dimension, right? What is the dimension of y? हाँ, दोनों सेम है क्योंकि माइनस हो चुका है, तो y डॉट स्टार z। See y into z, it is printing z, right? सबको दिख रहा है? कोई कंफर्म कर दो कि सबको समझ में आया कि मतलब किसी को समझ में आया। यहाँ पे फर्स्ट रो इस ये वाला एलिमेंट इसके साथ इंटू हुआ। अगर मैं इसको थोड़ा चेंज कर दूं, रुको y को थोड़ा चेंज करता हूँ ताकि तो 6315 से इंटू करेगा तो 0.0 ये नंबर आएगा। तो यहाँ पे एलिमेंट वाइज इंटू हो रहा है, ठीक है। यहाँ पे नॉर्मल मैट्रिक्स मल्टीप्लिकेशन नहीं हो रहा है। तो उसके लिए हम क्या यूज करेंगे, हम लोग पहले जो पहला जो है मैट्रिक्स उसको लिखेंगे, फिर डॉट लिखेंगे, ठीक है। वी विल बी यूजिंग डॉट, ओके। एवरीवन अंडरस्टूड? लेट्स से वी आर प्रिंटिंग तो फटाफट
I don't
बोल दो
understand. Can you please explain it again?
वाला पार्ट, विच पार्ट? हेलो,
हाँ,
कौन सा पार्ट समझ में नहीं आया, फिर से बोले तो।
वही जो z डॉट स्टार वही।
अच्छा देखो, z डॉट स्टार वाई अगर करूंगा, एक कैलकुलेटर है, लैपटॉप में कैलकुलेटर होगा ना? यू आर हैविंग अ
हाँ हाँ।
कैलकुलेटर इन योर लैपटॉप, राइट? सो जस्ट ओपन इट and just multiply the 0.6324, that is the first element and of z and first element of y. It is visible, right? Let me
0.0997।
हाँ, बाकी सब एलिमेंट के लिए एक बार ट्राई करो, दो मतलब दूसरा सेकंड एलिमेंट के लिए, मींस फर्स्ट रो सेकंड
अच्छा,
कॉलम।
ये एक इंडिविजुअल एलिमेंट के लिए मल्टीप्लिकेशन है ना?
हाँ, so we are multiplying the individual element, okay. लाइक A11 into B11, A12 into B12, IJ इंडेक्सिंग पता है ना लोगों को, तुम सबको?
हाँ
तो बस वही कर रहे हैं यहाँ पे.
अच्छा
Let's say we are writing y is equal to z. You know the symbol of power, right? ये arrow. तो ये क्या? Increment dimension for raising a matrix to power. Okay. What is it? Okay, it should be square. Hello. देखो ये इसका स्क्वायर नहीं हो सकता क्योंकि z का डायमेंशन क्या है? 3x2 है ना. 3x2 और 3x2 तो इंटू नहीं हो पाएगा. तो यहाँ पे इसलिए मैंने 3x3 का स्क्वायर मैट्रिक्स बनाया. उसको z को प्रिंट करते हैं. z को प्रिंट किया. Now let's say y is equal to z. Okay. Let's see what it is. So it is printing the square matrix. That is, it is multiplying z into z. Okay. It is printing z into z, normal matrix multiplication. Now if I write y is equal to z dot square, बता सकते हैं इसमें क्या होगा? Anyone? गेस करो, बहुत आसान है, अभी मैंने डिस्कस किया थोड़ा.
Z into Z.
नहीं, z into z तो normally it will be done by z raised to 2. I am writing z dot raised to 2.
एलिमेंट कॉरेस्पॉन्डिंग एलिमेंट के साथ मल्टीप्लिकेशन.
नहीं, यहाँ पे क्या होगा ना, here the individual element will be square. Okay, so if I am writing 0.4, तो यहाँ पे इंडिविजुअल एलिमेंट जो है वो स्क्वायर होगा. लाइक जो फर्स्ट एलिमेंट है, फर्स्ट रो फर्स्ट कॉलम, ये वाला स्क्वायर हो जाएगा. सेकंड रो फर्स्ट रो सेकंड कॉलम, ये अपने आप में स्क्वायर होगा. ठीक है, समझ में आ रहा है? लेट्स से मैं बताता हूँ, रुको. y is equal to y दिख रहा है 2 3 4. ओके, y is equal to 2 3 4 दिख रहा है? हाँ या ना बोलो. देखो थोड़ा इंटरेक्ट करोगे तो जल्दी मुझे भी पता चलेगा हाँ तुम लोगों को समझ में आ रहा है. ये दिख रहा है y is equal to 2 3 4? ये सुनो तो बोल दो यार.
अभी
हेलो. हाँ तो अच्छा, आप खाली कोई ये बताओ कि ये y का ये इसका मैट्रिक्स स्क्वायर कर पाएंगे हम लोग? यहाँ पे y स्क्वायर लिखेंगे तो होगा, इम्प्लीमेंट होगा. y इंटू वाई होगा यहाँ पे? पॉसिबल है?
नहीं होगा.
नहीं होगा. तो हाँ पर देखो, हम यहाँ पे हम लिखेंगे z इज इक्वल टू वाई स्क्वायर, तो यहाँ पे नहीं होगा. सही है, एरर आ गया, नहीं होगा. अब मैं लिखूँ z इज इक्वल टू वाई डॉट रेज टू 2. देखो मैंने सिर्फ यहाँ पे डॉट ऐड किया, y z इज इक्वल टू वाई डॉट रेज टू 2. अब देखो हो गया. तो यहाँ पे समझ में आया यहाँ पे क्या हो रहा है? तो क्लियर हो गया होगा.
अभी
हाँ, तो डॉट क्या करता है? सिर्फ इंडिविजुअल एलिमेंट पे काम करता है. ठीक है. Addition and subtraction is by default is done on individual element, but square and multiplication it is done on in matrix in another method. Okay, so if you want to multiply or square the individual element, then we will use dot. Okay, सबको समझ में आया? अगर हम लोग इंडिविजुअल एलिमेंट में काम करना चाहेंगे तो जो काम नॉर्मल नहीं होता इंडिविजुअली में, जैसे मल्टीप्लिकेशन हो गया, स्क्वायर हो गया, ये नॉर्मली इंडिविजुअल एलिमेंट में नहीं होता. इसका एक अलग तरीका है मैट्रिक्स में ना करने का, मल्टीप्लाई करने का. तो अगर हमको इंडिविजुअल एलिमेंट में करना है तो हम लोग डॉट का यूज करेंगे. ठीक है, सबको समझ में आ गई ये चीज? आगे बढ़ते हैं. हाँ, अगर इफ यू वांट टू फाइंड द साइज ऑफ अ मैट्रिक्स, वी कैन यूज साइज फंक्शन. लाइक z इज इक्वल टू 496, सो वी विल राइट a इज इक्वल टू साइज z. So it will print A13 means row is equal to 1 and 3 is equal to column is equal to 3, means we are having first row, 1 row and 3 column. Okay, so size returns 2 values. You can also write like this: row column is equal to size z. Row is equal to 1, column is equal to 3. If we want to ignore some argument like row or column here, we can write like this. We can use tilde function, tilde symbol. Sorry. Let's try once again. अच्छा, जब हम लोग टिल्डे यूज करें तो हमें कॉमा यूज करना पड़ेगा, ठीक है। यहाँ पे समझ में आया किसी को क्या हुआ? हेलो। हाँ, थोड़ा ज़्यादा टाइम हो रहा है, मुझे समझ में आ रहा है, थोड़ा लेंदी हो गया आज का वर्कशॉप। नेक्स्ट टाइम थोड़ा मैं ध्यान रखूंगा। और यहाँ पे समझ में आ गया ना, यहाँ पे क्या हुआ था एरर मेरा यहाँ पे? हेलो, फटाफट हाँ ना बोलो तो मैं भी जल्दी जल्दी करूँ। देखो यहाँ पे अगर मेरे को कोई भी आर्गुमेंट इग्नोर करना है, फर्स्ट को या सेकंड को, तो उसमें टिल्डे लिख देंगे और वहाँ पे कॉमा देना पड़ेगा, ठीक है। बट नॉर्मल केस में हम लोग को कॉमा नहीं देना पड़ेगा। जैसे रो कॉलम में निकालना था, रो में क्या डालना, कॉलम में क्या डालना, तो हमें कॉमा यूज नहीं करना था बस। इंडेक्सिंग से मैं समझा ही दिया था। अब एक लास्ट इंडेक्सिंग बता ही देता हूँ यहाँ पे। A is equal to random function it is creating a random matrix of 2 cross 3 size. If I'm writing B is equal to A, it will print the last element, okay? तो ये एंड का मतलब होता है लास्ट इंडेक्सिंग में चला जाता है, ठीक है। किसी का डाउट? एंड विल प्रिंट द लास्ट एलिमेंट, ओके, नथिंग एल्स। किसी कुछ पूछना?
हाँ भैया, हाँ भैया।
ठीक है। अब तक की जो पढ़ा है उसमें किसी को कोई डाउट है? मैटलैब में किसी को कोई डाउट हुआ? हाँ, कोई डाउट मैटलैब में किसी को भी? इसमें प्रिंट नहीं होता, छोड़ो। आज का वर्कशॉप काफी लंबा खींच गया, तो मैं प्लॉट नेक्स्ट वर्कशॉप में बता दूंगा, ठीक है। किसी को मैटलैब में कोई भी डाउट? Anyone is having any doubt in whatever I have discussed in the MATLAB today? हाँ ना कुछ भी बोल दो यार।
नहीं भैया।
सेकेंड ईयर से कोई है आज? पिछली बार तो मैंने CommNet का वर्कशॉप अटेंड किया था।
हाँ भाई।
तो बहुत ही सिमिलर रहा होगा। कुछ याद था पिछले बार कि इस बार कुछ हेल्प हुआ कि मतलब सब कुछ याद था पुराना वाला? मतलब सब कुछ याद था पहले वाला वर्कशॉप से कि आज कुछ फिर से कुछ लगा कि हाँ ये तो भूल ही गया था?
हाँ भैया, मतलब मैटलैब थोड़ा सा इतना ध्यान नहीं दिया था तब।
अच्छा, अब बाकी बेसिक्स में कोई डाउट है जैसे जो थ्योरी पढ़ाया मैंने?
नहीं भैया, वो एक्चुअली हम लोगों ने सिग्नल सिस्टम्स भी क्लास में कर लिया ना, तो थोड़ा सा रिलेटेबल लग रहा था।
अच्छा, कहीं पे ऐसा लगा कि हम कुछ गलत बोल रहे हैं, मतलब मैं कुछ गलत बोल दिया?
नहीं भैया, सही चल रहा
बोल
है।
सकते। बाकी फर्स्ट ईयर से कोई एक जन रिस्पॉन्स करो। एनीवन फ्रॉम द फर्स्ट ईयर? सब फर्स्ट ईयर चले गए क्या? ज्यादा लंबा हो गया आज का वर्कशॉप। एनीवन फ्रॉम द फर्स्ट ईयर? हाँ,
ठीक ही है, आज का वर्कशॉप ठीक ही है।
फर्स्ट ईयर से हो तुम?
हाँ हाँ,
क्या नाम है?
उग्नेश्वर कुंडू।
1 मिनट, कोई मीटिंग में तो। हाँ, क्या नाम बोला, फिर से रिपीट करोगे? सॉरी, सुनाई नहीं दिया।
उग्नेश्वर कुंडू।
अच्छा, कहाँ से हो तुम?
कोलकाता। कोलकाता।
कोलकाता कहाँ से?
गोड़िया गोड़िया।
गोड़िया। मास्टर द सॉल्यूशन पता होगा तो। मेट्रो में गए हो ना? हेलो अग्नि।
हाँ हाँ
हाँ,
हाँ
मास्टर
हाँ।
द सॉल्यूशन में पता है ना? मैं भी
मास्टर द
तुम्हारे तुमसे 3
सोल्यूशन वो
किलोमीटर दूर।
बागदोनी एरिया के लिए।
हाँ हाँ हाँ, मैं वही रहता हूँ।
अच्छा, मैं वो शहीद खुदीराम में उसके पास ही रहता हूँ।
अच्छा, चलो जान के अच्छा लगा। आज का वर्कशॉप में कुछ बोलना चाहोगे? मतलब समझ में आया कुछ थ्योरी सब? एक बार माइक
हाँ हाँ समझ में
कैमरा
आया।
ऑन कर सकते हो? कैमरा, हेलो, कैमरा ऑन कर सकते हो?
हाँ करो।
तो वर्कशॉप कैसा लगा? ऑनेस्ट रिव्यू देना थोड़ा। समझ आया?
हाँ
हाँ, थोड़ा लंबा चला गया ना आज
हाँ
का
हाँ
वर्कशॉप।
बिल्कुल।
ठीक है, ये सब अच्छे से ध्यान से देख लेना, ठीक है? एक बार मैटलैब में तुम्हारा मैटलैब इंस्टॉल हुआ?
हाँ इंस्टॉल हुआ।
कौन सा
मतलब
इंस्टॉल
आप
किया?
जो वो दिया था डॉक्यूमेंट में, उसमें से लिंक नहीं खुल रहा। बोल रहा कि लिंक एग्जिस्ट ही नहीं करता। तो वैसे
अच्छा
मतलब ऐसे ही मतलब इंस्टॉल कर लिया।
अच्छा अच्छा, ठीक है, चलो ठीक है, वो मैं देखूंगा उस लिंक क्यों नहीं खुल रहा। वो प्रीवियस ईयर का है, मैंने कुछ देखा नहीं था उसको ध्यान से अपना अच्छे से। ठीक है, चलो बाकियों
हाँ
में
ठीक है
किसी को
बाय।
कोई भी डाउट? ठीक है अग्नि, थैंक्स। बाकी किसी को कोई भी डाउट या किसी का कोई भी सजेशन, कुछ बोलना हो किसी को? एनीवन वांट टू से समथिंग, हैविंग एनी डाउट और एनीथिंग?
भैया हमें जो अभी आपने स्लाइड शो की थी तो उनकी पीडीएफ मिल सकती है?
हाँ हाँ, पीडीएफ सब शेयर हो जाएगा। पीडीएफ शेयर हो जाएगा, जितना भी मैंने मैटलैब में जो भी लिखा कोड वो भी शेयर हो जाएगा। एवरीथिंग विल बी शेयर्ड, ओके, डोंट वरी। जितेश, फ्रॉम विच ईयर? फर्स्ट ईयर, ओके। फ्रॉम वेयर, विच स्टेट?
राजस्थान, कोटा।
राजस्थान, कोटा। अच्छा, तो कौन सा कोचिंग इंस्टीट्यूट ज्वाइन किए थे कि घर से?
घर से किया था, खुद से।
वेरी गुड। और किसी को कोई डाउट? देखो मटेरियल सब शेयर हो जाएंगे, ठीक है, उसका टेंशन मतलब। बाकी नेक्स्ट वर्कशॉप में ध्यान दूंगा। थोड़ा थोड़ा स्लो हो गया था क्या आज का वर्कशॉप?
हाँ हो गया था थोड़ा।
अच्छा ठीक है। देखो
लेकिन ठीक है, कोई बात
थोड़ा ना तुम लोग थोड़ा रिस्पॉन्स कर दिया करो, क्योंकि मेरे को लगता है कि मतलब बैचेस नहीं समझ में आ रहा क्या, तो मैं ज़्यादा टानता हूँ, मतलब मैं ज़्यादा देर बोलता हूँ। अगर यस भैया या फिर कुछ भी यस कुछ रिस्पॉन्स कर दिया करो ना, तो मुझे पता चल जाए कि हाँ समझ में आ गया है। तो ये मैं ध्यान रखूंगा, ये मेरा पहला वर्कशॉप है। थैंकफुल, आई एम सो, तुम लोग का धन्यवाद, तुम लोगों ने ज्वाइन किया। थैंक्स टू ऑल ऑफ यू फॉर ज्वाइनिंग अस, ओके।